Assalamualaikum and hello to Dr. Jumail. I'm Cairo, and this is our group presentation video for assignment 2. So our group is Abdullah and Anindita and me. So for the next agenda, I'll pass to Abdullah.
Hello, Doctor. So now we'll be presenting the first process. I'm going to be sharing my screen with this. Can you share my screen? Can the host please let me share the screen? Honey, you there? Thank you. Okay, so here is the code. Sorry about that. So this is process 1. So the first thing is we import the CV library. The second thing we do is we load the images. So the first image, we're using the imRead function or the image read function for both images. The first one reads the noised image. So we are using the gun image for this example. And the second one here reads the original, the non-noised image. So the first operation or first method that we're using in this process is that we're applying a median filter to the image, the noised one, and with a kernel size of 5. So then that image, after applying this filter, is saved in this variable called median here. Next method or operation that we'll be performing is the brightening. We're using the add weighted function. And what basically this function does is it takes the median image here after applying the filter, and it multiplies every pixel by 1.2. So to increase the brightness of that image. And that is then later saved here in brightened. Next step is will be the third operation, where we will be turning this image into a grayscale image using this function right here, and we will be setting the color BGR to gray flat to the brightened image. Then that will be saved in the gray variable here. Next up, you'll be finding the minimum and maximum pixels in this gray image using this function, min and max log. That is then later used in the last and final method, where we will be stretching the image in order to increase the contrast by using this function called normalize. We will be setting the minimum pixel to 0, while the maximum pixel will be set to 255. Later, all the images, all the operations that we've done here. So we have the original, the noised, which is the salt and pepper image, the denoised, which is the median, and then brighten, which is the brightened, then the contrast, which is the stretched image here. So we will now be running the file to look at. So now we will be running the program in order to view the outputs and the images. Okay, so here are the images. So the first one, you have the original image, the non-noised one, and then the second one, which is the salt and pepper image. And then we have this window right here that displays the image after applying the median filter. As you can see, most of the salt and pepper effects are in this image are removed. As you can see, the background in this image is mostly white. Next up, we perform the brightening operation, which is this window right here. And basically this makes the background a lot more whiter in order to match it with this original image, as you can see here. So they are very similar. Next up, we perform the contrast operation by stretching the image. And this will be the final output, as you can see here. So they look a lot alike. Very similar. So now I will be passing to Annie, where we will be she will be explaining the process 2 code, and then after that we will be running the simulating file for both the images. Annie, the floor is yours.
Thank you, Abdullah. Then I'll share my process to code. Okay, so for the process two is it starts with the same function, which is we read the images first. So for this process two, the sample image we are using is image 60, and after that we use the median blur function to remove the salt and pepper noise, and then the kernel use here is 5. And after that, because we have to smoothen the whole image a little bit, for that, we use the Gaussian blur, and then the kernel use here is 5.5. And also we get the median file from this median variable. So we can load the salt and pepper removed image into the smooth function. And after that, we also have sharpen function, which mainly gets the sharpen kernel in this array form. And we declare the array, which is for mainly for the sharpen function. And then we use the filter 2D function that's already built in. And we again load the smooth image here that we previously did. And then after that, we use -1. This is mainly for like making it more brighter. And after that, we use the sharpen kernel to load the sharpened image. And after that, the main thing we do is to write the image in the drive so that we can store the image later, the noiseless image. And after that, we have to show our output. So this is showing the original image, the noise image, and also the restored image. And so now I'll show the whole result for the image. Yeah, so as you can see, this is the original, this is the restored, and you can see the noise. So compared side by side, you can see the noise. The restored one has less salt and pepper noise and also is less blurry compared to the previous noise image. And this is the sample image for the process two. So now I'll pass to Khairul for explaining the similarity.py.
Wait, should I? All right. So for the next part is the similarity test. So first of all, we need to boot the command prompt, and then we're gonna write cd to change the directory, and we paste the file directory. Okay, and then we write similarity.py, so we can run the file, and then choose the image that we're about to like compare the similarities. So it's original slash gun.jpg and also the restored one. So it's on the process one. All right, as you can see, the similarity is 83.37%. So and the threshold value of 10. Okay, so yeah, the pictures have quite similar details, but it's the right side is quite blurry.
So this image is for the process one. Now we'll be moving to the second similarity test, where we test the process, one of the process two images.
So I'm gonna see that as well.
Okay, so we'll change the directory again. Right, so now we'll be testing the process two image. So we first change the directory again. Then we run the file, similarity. Then we add the two images. So the first one is the original image. We'll be using the baby image, this example. Then the next one is the process, or the restored image using process two. As you can see, Here are the results. So we've used the default threshold value, which is 10, and the similarity is 58.83. All right, okay. So I believe that is the end of this video presentation. Thank you, doctor, for listening. Have a nice day.